This is the first lecture in a two-part series on z-scores. So far, I've talked about ways of describing central tendency, like the mean, median, and mode. I've also talked about describing how data is dispersed about the mean, with things like variance and standard deviation. So now I'm going to talk about z-scores. Z-scores are standardized values that can be used to compare scores in different distributions. So I'm going to give you an example of that. In my example, for the past 2 years, Joe has been in a bowling league. For the first year, the league average was 181, that's the population mean. The standard deviation was 12, that's the population standard deviation. And Joe's score in the final game of that year was 187. Now, in the second year, the league average was 182, the standard deviation was 6, and Joe's score in the final game was 185. Now, obviously, in the first year, his score in the final game is higher than it was in the second year. But what I want to know is, compared to the rest of the league, in which year was Joe's score in the final game better? So we're going to calculate a z-score using this equation. Now, what a z-score really is it tells us how far above or below we are, the mean. Basically, it tells us how many standard deviations we are above or below the mean. So for the first year, I put in Joe's score of 187, which is x, the population mean, which is 181, and the standard deviation, which is 12. And I calculate a z-score of 0.5. So that means we're 0.5, or about half of a standard deviation above the mean. Now for the second one, I put in Joe's score of 185, which is x. I put in the league average, the population mean, which is 182. And I put in the standard deviation, which is 5. And I get a z-score of 0.6, which means we are 0.6 standard deviations above the mean. So let me show you what those distributions look like. For the first year of stats, we have 181, the mean of 181 with a standard deviation of 12. And for the second year stats, we have a mean of 182 with a standard deviation of 5. So in the first year, he got a score of 187 in the final game, and in the second year he got a score of 185. But now when you look at these graphs, you can see that compared to the rest of the distribution, compared to every other score in the distribution, the 185 was actually higher than the 187. The 187 was only 0.5 standard deviations above the mean, whereas the 185 was 0.6 standard deviations above the mean. So in this case, the 185 was actually better than the 187 when comparing all the other scores within that year. So that's an example of how z-scores can be used to compare scores within different distributions. So you can see how the raw score might be inaccurate, but when you compare it to a z-score, we can actually see which score is better. And that is a z-score.